Welcome everyone. Let's start with a question. Have you ever thought about what's going on in your dog's brain when you are talking to him or to anyone else? Those who have been following our research for a long time know that ethology nowadays often appears integrated with other disciplines. This time I report on the results of a study that investigated both the behavior and the brain function of dogs and tried to find some associations between them. We developed completely non-invasive methods to study the brain function of family dogs, for example using EEG or functional magnetic resonance imaging, fMRI. The dog is an ideal subject for such research for two reasons. First, nowadays we think of the dog pretty much as a family member or as a friend, and we want to know much more about how they think, how they feel. On the other hand, researchers tend to use the dog as a kind of new model species. To better understand some general human brain responses. In this study, our goal was to figure out how the dog's brain response to human speech is affected by the dog's relationship with the speaker. I just want to show you that what I mean by entirely non-invasive methods. First of all, it's important because this is what ensures the comparability of these studies to that of the human investigations. So we really need the dogs to lie still for 8 minutes, absolute motionless, without fixation, sedation. So unlike other animal experiments, we don't use any coercion or sedative. The dogs are measured in the very same way as children. Of course, we use positive reinforcement and conditioning and cheese and treat, but, and that's what I want to show you, we also use social learning, so-called model rival training. So on the video you can see what I mean. What you need to watch, that's the young dog, the white one or the cream one. The video was made just to to show how we train the grey dog, the Cairn Terrier, but it turned out that we catched something. So what we try to do is to have fun and praise and love the dog which is on the bed, the fMRI bed, and to make the other dog, he's just watching. So we want to make it think that it's really fun to be on the bed. So it's really good to be there, and he really wants to be there. We don't take care about the little one. We just talk about the other one. And now he thought that that's his choice, that's his turn. So now you can see it's not about food because there's no food in the system, and he just didn't want to be together with the other dog because the other dog is now not there. So he just wanted to be at the place where the party is going on. So that's it, and you can see that he's happy. There we don't repeat commands or use food or any frustration or anything. So that's about fun, having fun on the scanner bed. Okay, so I hope you believe me now. So what do we already know from our previous fMRI studies? These studies have shown that the dog and human brain process pretty similarly the emotionally balanced human and dog vocalizations. And the dog brain can make a difference between the voices of two speakers, even if they are unfamiliar to the dogs. And it turned out that when we praise the dog not just the tone of the voice, but also the meaning of the words matter. So a different area of the dog brain processes the meaning of the words and the tone of the voice. And most importantly, there is a reward sensitive area that responds most when both the tone and the meaning were rewarding. Okay, we also know from others' research that in children, the voice of the mother, even the neutral voice of the mother, activates the reward response in the children's brain. So, of course, our question was if we can find some similar associations in case of the dogs, because the mother's voice appears as a kind of source of joy in the infant's brain. And we wanted to know if we can find anything similar in case of dogs. So you can see on the figure that the dog who was lying in the scanner bed could see both the familiar person and the owner during the whole test. And he was listening to the owner and the familiar person, the voice of them through headset, and we expected that only the owner's voice would appear as a source of joy in the dog's brain during this experiment. We had several different questions. If the owner's talk elicit a stronger brain response in reward sensitive areas than that of the familiar person, and of course if is this brain response affected by the content of the speech, if it's praising or a neutral speech. We used 4 different stimulus types. The stimulus could be the voice, could come either from the owner or from a familiar person, and it could be either neutral, reading a recipe, or praising. I show you. Of course. Okay, I know it's Hungarian, but you could hear that was the praising one. And that was reading a recipe. That's a neutral one. Okay, let's see some results. We could show the expected effect in 2 areas that act as a sort of reward center in the brain. In the left amygdala, you can see the role of the praise, that it's more activation for both the owner and the familiar person's praise than for their neutral speech. Okay, but what about the relationship with the speaker? The brain activity in the left caudate nucleus would show you something about the role of the owner. So here's the owner's praise, what really has an effect, and neither of the other voices could have an effect. Okay, but what about the owner's voice? Just the neutral voice, just like in case of infants. Would it have an effect as well in a reward center in the brain of the dog? So now we need to talk a little bit about attachment. That was our behavior test, because our hypothesis was that the level of the attachment to the owner affects the dog's brain responses elicited by the owner's speech, even her neutral speech. But it's important to stress that attachment is not just love. So we cannot measure love, but we can measure attachment. So that's a behavioral system which is based on the dependence of the attached individual from the mother in case of the infant, and from the owner in case of the dog. And it's based on the security providing role of the mother or the owner. So yes, we can measure attachment. There is a standard laboratory procedure, the strain situation test, for this purpose, and it's based on trying to evoke sort of moderate stress in the attached individual, the infant, or in our case in the dog, because the test is carried out at a strange place, and the infant or the dog is sometimes alone, so in separation, which is stressful, and sometimes the infant or the dog is with a stranger, and especially when the owner is not, or the mother is not there, so in separation, it's stressful again. So the whole situation evokes moderate stress, which activates the attachment behavior, and that's what we need here, because attachment can be observed only if it's activated. For example, a very typical behavior element is proximity seeking, what we can observe in such cases, and we can characterize the attachment behavior by a score. And these behavior tests have shown that the dog-owner bond is pretty much similar to the child-mother bond at the behavior level, of course. So, our hypothesis was that the attachment between the dog and the owner, so the dog's attachment towards the owner, can have something to do with the brain response when the dog is listening to the owner's neutral or praising and neutral voice. So the first result shows us the reward value of the owner's speech, that's both the praising and the neutral speech of the owner, versus that of the familiar person. Each dot represents a dog. The x-axis shows the attachment score, and the y-axis shows how much stronger activity the dog's brains showed to the owner's voice than to the familiar person's voice. So the line, the trend line, displays the relationship between attachment, the score from the behavior test, this one, and the brain response. You can see that the higher the attachment scores were, that is, the stronger attachment behavior the dog showed in the behavior test, the greater the reward value of the owner's speech was in the dog's brain. Okay, the owner's speech was more rewarding than that of the familiar person, but what if this was only due to the owner's praise? Because here we handled everything together, praise and neutral. So what about just the owner's speech, the neutral voice, reading the recipe? Finally, the last figure shows the most important result, the reward value of the owner's neutral speech. So here only the analysis of brain responses to neutral speech can be seen. When the speakers read the recipes, and here what we can see is that we observed an attachment-dependent reward response, again to the only to the owner's neutral voice. That is, in the brains of dogs that showed a strong attachment in the behavior test towards the owner. So even the dog's neutral speech for them was rewarding. In sum, the dog's relationship with the speaker affects the dog's brain response to human speech in several ways. Of course, the owner's praise is more rewarding than that of the familiar person's. Yeah, that seems quite natural, but it's sometimes it's really, it's worth proving it. But a most important result here is that in case of a strong attachment relationship, the owner's neutral speech, even the owner's neutral speech, is rewarding for the dog's brain, just like in case of the infant-mother relationship. So we can conclude that we have similarities not just at the behavior level, but similar brain mechanisms underlie the dog owner and the child-mother relationships, which provide further evidence for us that the child-mother attachment and the dog owner attachment have surprisingly similar features. And that's very important for us, because that really provides a stable basis to use the dog as a model species for many other research areas. This research was a huge team effort, of course, thanks to the co-authors and of course basically many thanks to the participating owners and their wonderful dogs who helped us and were really, I hope that they had fun during the experiments, even in the fMRI. Thank you for your attention.